right, welcome back to section 14.1. We're going to continue on by talking about rotations. Rotations can be a little tricky. We're going to rotate or turn about a point through a given angle. And this is a transformation and the end result of rotating all points in the plane about a fixed point through a fixed angle. To illustrate a rotation about a point, you're going to put a transparency on a tabletop or thin piece of paper, hold one point on that thin piece of paper fixed by pressing the end of maybe a paper clip down on the point, and then just rotate the transparency about that point. And you're gonna see a video of that in your Desmos later. So now just imagine rotating all the points on the plane instead of just the points on the transparency. This movement would produce a rotation about a fixed point. So we're kind of imagining this plane rotating according to the fixed angle. So if we call this the center, this is where you would place your pencil to hold the transparency down, and here is V, and it looks like we're actually going to go the other way on this one. And so we're holding it down here, and then we're going to rotate the whole thin paper on the top, the transparency, all the way to this angle amount to V. And this would be, a clockwise rotation, and I don't know the angle here, but whatever angle that is, and that same distance, remember, if W was here, then when we rotate it as our pencil holds A, we're going to get that result of W prime. So now notice that the points farther from A, so look how far V is from A and how close X is. The points that are farther from A move a greater distance. So see how X just goes just a little bit? But they're all rotating through the same angle. So that can be a little bit confusing if you say like, oh, they're not moving the same distance. But it has to do with how far away they are from that center point. Let's look at an example here. So we've got our X and Y. They want us to draw two shapes that are not symmetrical. All right, so let's take a peek here. So let's do maybe this triangle here. And then let's do a weird shape here. Okay. So we've got our two shapes, and we're going to draw the result of rotating the shapes 180 degrees around the origin. Okay. So, and you know what? Okay, that's fine. So we're going 180 degrees around this origin point. So let's just look at this point here. Now, remember that a circle is 360 degrees. So we're going to go half of a circle. So we're going to go halfway to 180 degrees. And that center point is my origin. So I am going essentially halfway around this coordinate plane. So I was about here. Okay, how far am I from the origin there? I'm about there. And I'm going to go all the way to over here, right? That's a 180 degree turn. So let's see where this point is going to end up. It's going to end up, I am 1, 2, 3, 4, 1, 2. I am going to end up right about there, because that's going to make a straight line, 180 degrees. All right, so what about this point here? Now this point here is a little bit different, right? To get to that point, and then I'm going to kind of come out over here. See, I'm making a different 180 degrees. It's not the same because I'm coming from a different point. And another way is you could say, hey, I've got 1 point, right? I know how far this needs to be. This needs to be 2 points away, 1, 2. It's going to be right about there. And you know what would be even better is if I grab my ruler, right? So we could really see these points. Let's clear these up so we can really get them. We're going 180 degrees. You can ignore that. So that is where that 180 degrees, half circle through that origin point. And you can see, oh, that's exactly where those are. And again, ignore that arrow there. So now if we've got this point here, we're going 180 degrees. We're going along that same line. So how far do we need to go along that same line? So we've got, this is our line here. We're going down 1, 2, 3, 4, 5, 6. So we're going to go down to 6 here. 1, 2, 3, 4, 5, 6. And we're going to go over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We're going to come right there. And that is our reflection of 180 degrees. So let's take a look in the other direction. So I'm just going to kind of clean this up here so we can look this way. Maybe I'll grab some new colors. How about that? All right, so this point here, we want a 180 degrees. Remember, that's halfway around the circle. That's a straight line. So that's kind of this line here. And so this point is 1, 2, 3 down, 1, 2, 3 down, 1, 2, 1, 2. So we're going to go about right there. Okay, and then this point here, 180 degrees. And again, you might be saying, I know it's going to be 1, 2, 3 away. 1, 2, 3. It should be right there. Let's see if it turns out that way. It should. We're going to go 180 degrees. That's that line right there. And that's 1, 2, 3 down, 1, 2, 3 down, and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Look at that. And we could rebuild it, right? We could just rebuild it based on, it's not going to change the shape of it. And so that is the reflection. So that is 180 degrees around the origin. These can be pretty tricky. All right, let's look at this example. Construct a 270 degree counterclockwise rotation about the point P. Okay, there's P. Now, 270 degrees about P. So let's just think about this for a second. If we've got the point here, and we've got, let's call this point right here. This point's right above it. So counterclockwise is going to move in this direction, and we want to go 270 degrees around P. So we want to go 270 degrees around P. Well, what's this distance? What's left over? Remember, it's 360, so what's left over is 90 degrees. So we really want to move in this direction. It's the same as moving in this direction, clockwise, 90 degrees. And there's no difference if you prefer to go counterclockwise 270, but 90 degrees, you know, I can make that. So if we want to go 90 degrees, that's a right angle. We want to make a right angle this way. Again, we do want to make 270 degrees that way. If you prefer that, you can think of it that way. So when we have our 90 degree angle, right, we want to move this distance around 90 degrees. So how far is that? 1, 2, 3, 4. 1, 2, 3, 4. So it's going to put us right over there. 1, 2, 3, 4. Okay. So then we've got this point here. We also want this to be 90 degrees, right? Here's our angle. Right? This is 90 degrees no matter how big you go. This is 90 degrees. So then how far is this from our center point? We want to kind of land on this 90 degree line. So that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And just double check. We should be 1, 2, 3 away, 1, 2, 3 away. So this would be B prime and this would be A prime. So now let's look at C. Again, we could just remake C according to this. C is on the same line as B. So C is going to kind of come this way, right? It's going to come this way 90 degrees, and it's going to be 1, 2, 3, 4, 5 away from B, above B. 1, 2, 3, 4, 5. And there is C prime. And that is the resulting triangle. And the only reason it looks funny is because these are a little bit smaller than this way, so that's why it looks like it changed shape, but it did not actually change shape. So you're going to go ahead and give these a try. Don't skip them. It is tricky to do these rotations. Press play when you're ready to see the solution. And there we go. When we come back, we'll finish up this section.